Assalamualaikum and good morning. Okay, on Sunday we have done the lecture on subtopic 2.1 is separable variable. Okay, we still in chapter 2. Okay, the topic is first order differential equation. Today we will discuss on the subtopic 2.2. Okay, I repeat again. Okay, for chapter 2.2, first order differential equation, we have 3 subtopic. Okay, 2.1 is separable variable. 2.2, first order linear differential equation. And 2.3 is application. Okay, 2.1 we have done. Okay, on Sunday. For today, we need to cover 2.2, first order linear differential equation. For subtopic 2.2, we know that is first order linear differential equation. For course learning outcome is at the end of this topic, students should be able to A. Solve first order linear differential equation by means of an integrating factor. Okay. Okay, let's see, we have equation, DE equation here. X dy over dx equal y square multiple with x plus 1. Okay, this is a DE equation. Okay, we know that we have learned before this method separable variable. Okay, we try to separate the function of fx and the function of qy. Okay, to separate, we need to divide by x, both side. Okay, and divide by y square, both side. Okay, that's why we can get 1 over y square dy equal to x plus 1 over x dx. Okay, we can see that we have split the function of x and the function of qy. Okay, y to by side of dy, kemudian the function of x is by side of dx. Next, we integrate both sides. Okay, and then we know that after integration both sides, we can get the general solution first. Okay, and then if the question are given initial value, we can get the particular solution. Okay, for this equation, we can solve by using separable variable. Okay, for this example, okay, that's why we can solve by separable variable. Okay, let's say we have another one equation. Okay, the equation is dy over dx minus y over x plus 1 equal to 1. Okay, we try to separate. Okay, that's mean, we need to bring, the second term to the right hand side. Okay, that's mean dy over dx equal 1 plus y over x plus 1. And then we try to get the same denominator, x plus 1. Okay, the equation is dy over dx equal x plus 1 plus y equal over x plus 1. Okay, we know that, this equation, we cannot separate the function of px and function of qy. Okay, this part we cannot separate. Okay, we can say as a cannot be separated. Okay, what should we do? Okay, it can only solve by using integrating factor. Okay, this type differential equation is called first order linear differential equation. Okay, for equation that cannot be separate, okay, actually we have another method is by using integrating factor. Okay, and then we must understand what is a first order linear differential equation. Okay, to understand what is a first order linear differential equation, okay, a first order linear differential equation is an equation of the form, okay, we have a standard form here, dy over dx plus function px y equal function qx. Okay, this is a standard form for first order linear. Okay, first order linear. Okay, why linear here? Because of the the variable y here. Okay, the variable y here is must be to the power of 1. Okay, to the power of 1 as a linear differential equation. Okay, make sure still remember that the standard equation for linear is dy over dx plus function pxy equal function qx. Okay, and then we must know that function px and function qx are continuous function of x or constant, okay, or constant, okay. Okay, function px in term of x or constant. Okay, for example, let's say we have dy over dx minus 5y equal exponent to the power of 5x. Okay, if we compare with the standard form here, we dy over dx plus pxy equal qx. Okay, we know that. Okay, what is the value for function px? Okay, the function px is negative 5. And then function qx equal to exponent to the power of 5x. Okay, make sure don't be careless. Okay, sometimes student always take the positive 5. Okay, actually the value for the function px is negative 5, not positive 5. Okay, for solve by using an integrating factor, you also have two solutions here. Okay, general solution. What is general solution? The general solution of a differential equation contain an arbitrary constant C. Example, y equal to 3x cubed plus C. Okay, for particular solution, okay, the particular solution of a differential equation contain a specific initial value and containing no constant. Okay, example, y equal to 3x to the power of 3 plus 2. The concept is same with the separable variable. Okay, now we look at the step how to solve by using an integrating factor. Okay, we have 5 steps here. Okay, to revise before this inseparable variable. Okay, we have 2 steps. Okay, but this one we have 5 steps to solve by using integrating factor. Okay, we go through step by step. Okay, first step 1. Okay, what is step 1? Okay, we need to rearrange the DE in the form. Okay, rearrange the DE in the form. Okay, form here is standard form for first order linear differential equation. Okay, the standard form here is dy over dx plus function pxy equal to function qx. Okay, this is a standard form for first order linear differential equation. Okay, for step one, we also need to find or to carry out the px. Okay, what is the function px and the function qx? Okay, we need to list down the function px and function qx by compare the standard form. Okay, that's for step one. Okay, go to the step 2. Okay, we need to find an integrating factor. Okay, integrating factor here is function Vx. Okay, equal exponent integration Px dx. Okay, to find function Vx, actually we have a formula. Okay, what is the formula for function Vx? The formula is exponent integration px dx. Okay, exponent to the power integrate a function px dx. Okay, make sure you write down the correct px. Okay, to find the integrating factor for function vx. Okay, function vx is integrating factor is a function of vx. Okay, that's for step 2. Okay, next for step 3, okay, we need to multiply the DE in step 1 with Vx, okay, function Vx. Okay, we just rewrite, okay, function Vx multiple with function DE equation in step 1. Okay, and then for step 4, okay, write the equation in the form. Okay, we need to write the equation is d over dx. Okay, d over dx vxy equal vx qx. Okay, function vx multiple with function qx. Okay, actually we know that, okay, in the box, okay, the right box, okay, is Vxy. Okay, we must write down Vxy. Okay, d over dx Vxy. And then for step 5, we need to integrate both sides of the equation with respect to x. Okay, we need to integrate both sides. And we know that, okay, for left side, we can get Vxy for the integration. And then we need to integrate the right side, okay, the product of Vx multiple with Qx. And then after integration, also we can get a general solution. That means after integration, you must put plus C. Okay, after integrate, put plus C. And then if the question are given condition, we substitute the value for X and Y to get the value for C. And then substitute back into general solution to find the particular solution. Okay, next we go to the example to more understanding the concept of integrating factor. Okay, we have example 1 here. Okay, the question is solve the differential equation dy over dx plus y over x equal x to the power of 3. Okay. Okay, first step, you know that first step we need to rewrite or rearrange in rearrange in standard form. Okay, for first order linear differential equation. Okay, the standard form here is dy over dx plus 1 over xy equal to x to the power of 3. Okay, we know that. Okay, the standard form here is dy over dx plus function px y equal to function qx. Okay, this one as a step 1. Okay, before we go to the step 2, okay, carry out what is the function of px and the function of qx. Okay, the function px is 1 over x. Okay, make sure it's correct, 1 over x, positive 1 over x. And then function qx is x to the power of 3. Okay, we have settled for step 1. Next, we go to the step 2. We need to find an integrating factor. The symbol is function Vx. Okay, the formula is exponent to the power of integration Px dx. Okay, that's why we put exponent integration 1 over x dx. And then integrate 1 over x, we can get ln x. Okay, integrate 1 over x is ln x. That's why exponent to the power of ln x. And then we simplify, we can get x only. Okay, make sure you need to simplify. If the function we can simplify. Okay, Vx equal to x. This one as a step 2. Okay, next. Okay, what for step 3? Okay. Okay, for step 3, okay, we need to multiply the DEs in step 1 kan. Okay, just rewrite. Okay, x multiple with dy over dx plus x multiply 1 over xy equal to x multiply x to the power of 3. Okay, that's why we multiply on the DE and step 1 with Vx. This is a step 3. Okay, for step 4, we need to rewrite d over dx. Okay, d over dx vxy. Okay. Okay, d over dx vxy. Okay, vx is x and the variable is y. Okay, equal to x to the power of 4. Okay. Okay. Should be the box 2 is Vx multiply with the variable y. Okay, actually, okay, this one, okay, d over dx, okay, if we differentiate d over dx xy, we can get the output, okay, as same as the left hand side. Okay, this is a, you know, we might use a product rule. Okay, this is d over dx xy is a input differentiate by using product rule. We can get as x dy over dx plus x multiple 1 over xy equal to x. Okay, multiple with y. Okay, is this true? Okay, d over dx xy we can get as the expression as the left hand side. Okay, actually, okay. Okay, d over dx xy equal to x dy over dx plus y. Okay. Okay, actually this one come from product rule. Okay, we have a product rule. The output for product rule. Okay, we need to express in differentiate. Okay, differentiate d over dx. Okay, this one for step 4. Okay, before we go to the step 5, okay, we need to do something. Okay, we need to multiply dx both side. Okay, in step 4, we multiply dx both side. Okay, that's why we can get dxy equal to x to the power of 4 dx. Okay, x to the power of 4 because of the x multiple with x to the power of 3. That's why we can get x to the power of 4. Okay, and then we integrate both sides. Okay, as a step 5, we integrate dxy equal to integrate x to the power of 4 dx. Okay, to the left side, okay, for your integration is xy. Okay, okay, integrate dxy is, we know the answer is xy equal, okay, for the right side, we can get x to the power of 5 over 5 plus c. And then express y into the term of x, we can get y equal to x to the power of 4 over 5 plus c over x as a final answer. Okay, we try to express y in term of x as simple as we can. Okay, this one we call general solution. Okay, that's for example 1. Okay, all the solution you must write down. Okay, cannot skip all the solution by using integrating factor. Okay, next we go to another example. Okay, for example 2, okay, solve dy over dx minus y over x plus 1 equal x. Okay, we know that we can solve by using an integrating factor because of this one we have y to the power of 1. Okay, the standard form for first order linear differential equation is still dy over dx plus function px y equal function qx. I just rewrite back. Okay, dy over dx plus negative over x plus 1 y equal x. Okay, this one is easy to carry out. Okay, the value for px and the value for qx, or the function of px and the function of qx. Okay, the function px is negative. Okay, negative 1 over x plus 1. And the function of qx is x. Okay, we settle for step 1. Next, we go to step 2. Okay, we need to find Vx or an integrating factor. Okay, we need to integrate exponent, integrate negative 1 over x plus 1 dx. Okay, we know that. Okay, we can get the answer is exponent negative ln absolute x plus 1. And then, Okay, x a negative 1 as the power for x plus 1. And then we simple exponent ln, we can get 1 over x plus 1. Okay, the answer for Vx is 1 over x plus 1 as a function Vx. Okay, we have settled for step 2. Okay, next for step 3, just rewrite, okay. 1 over x plus 1 multiple with dy over dx minus 1 over x plus 1 multiple with 1 over x plus 1 multiple with y equal 1 over x plus 1 multiple with x. Okay, this is a step 3. Okay, be careful for step 4. We need to rewrite d over dx. Okay, d over dx vxy. Okay, d over dx. Okay, d over dx. Okay, what is vx? Vx is 1 over x plus 1 and then variable y equal. Okay, for we simplify the right side, we can get x over x plus 1. Okay, make sure we get the correct right box here. Okay, vxy. Okay, this one is a step 4. Okay, before we go to the step 5, okay, we need to do something is we need to differentiate dx both side. Okay, we differentiate dx both side. Okay, and then after that we integrate both side. Okay, integrate dy over x plus 1 equal integrate x over x plus 1 dx. Okay, this is a step 5 and then we need to solve. Okay, we know that for the right side, x over x plus 1, we cannot simplify, okay, to integrate. Okay, that's why we might use something, okay, to integrate. This one, okay, I use the long division, okay, to spread, okay, the factor. Okay, that's why we can get 1 minus 1 over x plus 1. Okay, or we can use substitution method. Okay, for integrate left side, integrate dy over x plus 1. Actually, we know that the answer is y over x plus 1 equal. For the right side is integrate 1 is x minus integrate 1 over x plus 1 is ln absolute x plus 1 plus c. Okay, don't forget plus c. Okay, this, okay, is a general solution. Okay, but before we need to express, okay, y in terms of x. It's a simple. Okay, the general solution is y equal to x plus 1 multiple with x minus ln absolute x plus 1 plus c. This is a general solution for the answer example 2. Okay, don't forget to show all the steps, okay, by using integrating factor. Okay, next, we try example 3, okay. Example 3 is solve dy over dt, okay, plus 2y over t equal cos t over t square, okay. Our derivative is dy over dt, okay, always dy over dx, but this one is dy over dt. That means the standard form here is different, okay. dy over dt plus pt, okay, y equal qt. Okay, our standard here is dy over dt plus pt, function pty equal to function qt. Okay, this is standard form. Okay, for first step is, okay, rearrange in standard form. Okay, dy over dx plus 2 over ty equal cos t over t square. Okay, cos t over t square. Okay, step 1. And then we compare with the standard form to find what is the value or the function of pt. Okay, function pt is equal to 2 over t, and then function qt is cos t over t square. Okay, next, okay, we need to find an integrating factor. Okay, the formula is exponent integration pt dt. Okay, that's why we can get exponent integration 2 over t dt. Okay, the answer is exponent 2 ln t. And then 2 become a t square. Okay, exponent ln t square. And then we simplify, we can get t square only. Okay, the answer for Vt is 2 t square. Okay, t square. Okay, this one is step 2. Okay, step 3, we multiply t square with the step 1. Okay, that's why we can get t square dy over dt plus t square multiple with 2 over ty equal cos t over t square multiple with t square. Okay, this is a step 3. Okay, for step 4, okay, we must write as d over dt, okay, not d over dx, okay, d over dt, d over dt, vt, vty, okay, that's why we get t square y equal to cos t. Okay, why we got cos t here? Because we have cancelled t square on the step 3. We can get cos t only. Okay, we know that the red box, okay, we must put vty. Okay, settle for step 4. Okay, to go to the step 5, okay, we need to do something is we multiple with dt both side. Okay, don't forget to multiple with dt both side. Okay. Okay. And then we integrate. Okay, we integrate both side. Integrate dt square y equal to integrate cos t dt. Integrate for the left side, we can get t square y. Okay, t square y. Okay, integrate left side, we can get t square y. And then for right side, integrate cos t is sin t plus c. Okay, sin t. Make sure we confirm that. Okay, integrate cos t is a positive sin t, not a negative. Differentiate cos t is negative sign. Okay, but integrate cos is positive sign. Okay, we can get the equation here is t square y equal sin t plus c. This is a general equation or general solution. Okay, for this question, we have an initial value or condition. Okay, we have condition here is y pi equal to 0. Y pi equal to 0. Okay, that means y equal to 0 when t equal to pi. Okay, y equal to 0 when t equal to pi. And then we substitute into equation, general solution, we can get, okay, c equal to 0 because of sin pi is 0. Okay, sin pi is 0. We can get c equal to 0. And then we substitute into general solution, the value for c, we can get t to the power of 2y equals sin t. Okay, because of the plus 0 here. And then we express y into term t, we can get y equal to sin t over t square as an answer for particular solution. Okay, y equal to sin t over t square as a particular solution. Okay, this example have a condition value. Okay, that means we need to find anti-particular solution. Okay, we have another example here. Okay, example 4. Okay, the question is solve exponent t dr over dt plus 2 exponent tr equal to 3. Okay, r0 equal to 2. Okay, we know that, okay, our derivative is dr over dt. That means the standard form here is dr over dt plus ptr. Okay, ptr. Okay, ptr equal qt. Okay, our standard form is dr over dt plus okay, dr over dt equal ptr equal qt. This is a standard form for example 4 when we want to use an integrating factor. Okay, when we look at the equation, we know that we have something, okay, at the side of dr over dt. We have exponent to the power of t. Okay, we need to make sure, okay, we need to, okay, to find, okay, untuk jadikan, okay, is one, okay. That means we need to divide, okay. Divide by exponent t both side. Okay, first we need to divide exponent t both side. That's why we can get dr over dt plus 2r equal to exponent 3 exponent negative to the power of negative t. Okay, dr over dt plus 2r equal 3 exponent to the power of negative t. Okay, when we divide by exponent t both side. Okay, and then we compare to the general. Okay, we compare to the standard form dr over dt plus function ptr equal to function qt. Okay, we can get, okay, the function pt is 2, okay, positive 2. And then the function qt is 3 exponent to the power of negative t. Okay. Next, we to find the integrating factor Vt. Integrating factor is Vt. Exponent integrate 2 dt. Okay, exponent integrate 2 dt is, the answer is exponent 2t. Okay, we cannot simplify. We just let the answer is exponent 2t only as a function Vt. Okay, this one for step 2. Okay, next for step 3, we multiple with VT with the equation in step 1. Okay, just rewrite. Okay, exponent to the power of 2t multiple dr over dt plus 2 exponent to the power of 2t multiple with r equal exponent 3 exponent to the power of 2t multiple with exponent to the power of negative t. Okay, this is for step 3. And then we need to revise, okay, not d over dx. Okay, this one is d over dt. Okay, d over dt vt r. Okay, because of r is a variable. Okay, independent variable. Okay, dr d over dt exponent. Okay, exponent to the power of 2t r equal to 3 exponent to the power of t. Okay. Okay, we must know we get the correct box here. Okay, VT R. Okay, for step 4. Okay, we multiple with dt both side. Okay, d exponent to the power of 2t r equal to 3 exponent to the power of t dt. Okay, and then we need to integrate. Okay, both side, integrate both side. For integration left hand side, we can get exponent to the power of 2t r equal, okay, integrate 3 exponent t. Okay, we can use a basic only for exponent. The answer is exponent 2t multiple with r for the left side equal, for the right side is 3 exponent to the power of t plus c. Okay, we let as a general solution, and then we substitute the value for r and for t. When t equal to 0, r equal to 2, we substitute into general solution. Okay, we can get the value for c is negative 1. Okay, value for c is negative 1. And then exponent to the power of 2t r equal 3 exponent to the power of t minus 1. And then we express r into term t. We can get r equal 1 over exponent to the power of 2t multiple with 3 exponent to the power of t minus 1. This is the answer for a particular solution. Okay, this is the answer for particular solution. Okay, example 4 also we have a condition that we need to find anti-particular solution. Okay, next for example 5, okay, we have solve y plus 1 dy over dx plus x equal to y minus 1. Given that x equal to 1, y equal to 1. Okay, for this differential equation, okay, we need to more careful because of, okay, always the dE is dy over dx, but this question is dx over dy. Okay, dx over dy. Okay, when our derivative is dx over dy, that means for standard form is dx over dy plus py, and then the variable is x equal qy. Okay, the standard form is dy over dx plus function px y equal function qy. Okay. For step 1, we need to divide y plus 1 both sides. Okay, we can get dy over dx plus 1 over y plus 1 multiple with x equal to y minus 1 over y plus 1. Okay. We know that when we compare with the standard form, the function px is 1 over y plus 1. And then the function qy is 2y minus 1 over y plus 1. Okay, next we to find integrating factor. Okay, vy equal exponent integration 1 over y plus 1 dy